our second question for today is, show that the vector 1 minus 1 is an element of the span of the vectors 1, 2 and 2, 4. Let's go ahead and solve this. So what we have to do is we have to show that this vector here, which is 1 and minus 1, is not an element of this set here, which is span of 1, 2 and 2, 4, right? Now, to do this, what we could do is we could consider that this statement is true. Basically not true, but we could say that this is an element. Let's consider that 1 minus 1 is an element of this span of the vectors. In that case, we would say that 1 minus 1 is equal to sum lambda 1 times the vector 1, 2 plus sum lambda 2 times the vector 2, 4, where the lambda 1 and lambda 2 are elements of the real numbers. Now, let's solve this a bit further. So here we would have 1 times lambda 1 and 2 times lambda 1 plus 2 times lambda 2 and 4 times lambda 2. That's equal to 1 minus 1 here. So solving it further, this would be lambda 1 plus 2 lambda 2, and here it's 2 lambda 1 plus 4 lambda 2. Now writing these as equations, you have here lambda 1 plus 2 lambda 2 is equal to 1. And for the second equation, we have 2 lambda 1 plus 4 lambda 2 is equal to minus 1. Now from here, the second equation, we can take out 2 as common. So let's do that. And if we take out here 2 as common, in that case, this would no more be a 2 and this would be a 2, right? So let's write that down here. So this here is lambda 1 plus 2 lambda 2 and 2 times that. Now instead of this, you could say that the 2 here, which is multiplying, will go on the other side and divide. So it will be minus 1 divided by 2, right? So this is gone from here in that case. Then we don't need to multiply it and put the brackets. Now in this situation here, what you're seeing is we have here lambda 1 plus 2 lambda 2 is equal to 1, and here we have lambda 1 plus 2 lambda 2 is equal to half. So it's the same two numbers, lambda 1 and lambda 2, and they both are only the lambda 2 in both the equations are being multiplied by 2, and you're just directly adding lambda 1. But both the times they are giving different solutions. At the first equation, they're giving the solution as 1. In the second equation, they're giving the solution as half. That's not possible. So you cannot have two numbers, lambda 1 and lambda 2, and solve it in this way where you are just taking the first number and multiplying 2 to the second number, but get two different answers, right? That's not possible. So in that case, this is not possible. And therefore, so you can just write here, this is not possible. Therefore, the set 1, or the vector, 1 minus 1 is not an element of the set of span of the vectors 1, 2 and 2, 4. There is one more way that I could show you that this is not possible, but that's not how you work it out, right? So why this is not possible is graphically, if I show you, maybe let's take black here. So you have the planes x and y here, and you have the point here 1, 2. So it's 1 here and 2 here. So that's your point 1, 2, the vector. And the next vector 2 comma 4 is actually here. So this is 2 here, and you have here, let me extend this here. So the 4 would be here somewhere. So as you can see over here, this is a straight line, right? 1 comma 1, the vector 1 2 and 2 4 actually lies on a straight line. So they are actually spanning the same line, and 1 comma minus 1, the vector that we have here, which is 1 comma minus 1, which is here, is out of that line, out of this line here, right? So that therefore it can never be an element of this span here, because this set over here, which is span one of the vectors 1 2 and 2 4, is only spanning this line. Anything in this line is spanned. So anything out of this line, as you can see, this point here or this vector here, which is 1 minus 1, is not an element of the line here, right? So that's graphically shown. And that's the end of this section.